Baseball is a game of split-second decisions. An average fastball in Major League Baseball is clocked at 93 miles per hour, which is about 150 kilometers per hour. The distance from the pitching mound to home plate is 60 feet, or 18.3 meters. Doing the calculations, this results in a total time of 0.44 seconds for the ball to reach its destination at home plate. By comparison, the average time it takes you to blink is about 400 milliseconds. So if you blink, you might miss it. With such little time to react, how do baseball players do it? It all involves split-second decision-making, a whole bunch of physics, and even a little bit of luck.
Jose Bautista of the Toronto Blue Jays is up to bat and smacks a home run over the Green Monster at Fenway Park against the Boston Red Sox. It sure looks pretty cool, but how exactly does he accomplish this amazing feat? It all begins with a simple choice: to swing or not to swing. Here's a video breaking down this process.
When the ball is released, the image of the ball enters the batter's eyes, where it's broken down into electrical impulses. The brain takes 110 milliseconds to decode this data. By now, the ball has already traveled 15 feet. While the batter is calculating the pitch's trajectory and whether or not to swing, the ball has traveled another 15 feet. Now is the moment of decision. He must start a swing with the ball still 25 feet away from the plate, or it will be too late. And in the last 15 feet, the brain and the eyes cannot work together fast enough, and the ball is essentially invisible.
Joey Bats likes what he sees, so he decides to swing away. Prior to the pitch being released, Jose gets into his batting stance and loads up. In this essential process, the hitter acts like a spring, loading themselves up with potential energy as they transfer their weight to their back leg. Then, choosing to swing, Jose unloads, turning this potential energy into kinetic energy and transferring it from his lower half to his upper half, where most of the motion takes place.
As a result, he can swing the bat a lot faster. Try it at home. Grab a bat and swing it while attempting keeping your feet planted and body stationary over than your arms. Then try it with a load up. The speed at which the ball is traveling at the moment of contact with the ball is crucial in determining how far and how fast the ball will travel after contact. A baseball bat averaging about 32 ounces, which is about 0.9 kilograms, is 6 times more massive than a baseball, about 5 ounces, meaning momentum increases significantly more when bat speed is increased as opposed to ball speed.
Now we get into the good stuff, the moment of collision, or in other words, the collision between the bat and the ball. The collision only lasts for about 1 millisecond, but in that time, the velocity of the ball changes from 90 miles per hour to more than 100 miles per hour in the opposite direction. This large change in momentum is based on a set of ideal circumstances for the collision. To hit a home run like the one Jose Bautista hit, a few things must happen first. Like we said, the bat speed at the moment of collision must be great enough so that impulse may also be greater. Additionally, an ideal home run would occur in an on-centered collision with the bat. That means the center of the bat will collide with the center of the ball for maximum impulse. This, however, is not so simple.
Baseball players often talk about the sweet spot of the bat. Although this is not a fixed definition and the spot changes for every baseball bat depending on mass, length, and material, we will assume it is the spot on the bat where ball speed after contact is maximized and the vibration in the bat is minimized. If you've ever played baseball before, you know how much it hurts to miss hit a ball. That is, not hit the ball on the sweet spot of the bat.
This is because a baseball bat has 2 bending modes, which are vibrations that occur at 2 different frequencies. The center of percussion, or the COP of a bat, is the area on the bat where these vibrations are minimized. This is important because minimal vibrations not only reduce pain, but also reduces the amount of energy used to create these vibrations, meaning more energy can be transferred to the ball and only the ball. Generally, the spot is about 2 inches wide and is located about 5 to 7 inches from the barrel end of the bat.
The third factor is the swing angle of the bat. The optimal angle of a projectile for maximum horizontal range is 45 degrees. This, however, is unrealistic, since the batter would have to take a severe uppercut swing and likely have greatly altered their swing to do so, losing a lot of velocity to do so, and therefore resulting in less distance. An ideal angle at the moment of collision for a home run swing would be about 20 degrees above horizontal, resulting in the projectile traveling further and higher without breaking down the fluidity of the swing.
Once this all happens, the ball simply becomes a projectile flying through the air and over the Green Monster, adding another monster home run to Jose Bautista's numbers.
Take me out to the ball.